Hello everyone, welcome to my channel Physics with Lipsy. My name is Lipsy Rana and you are doing physics with me. We are doing the syllabus of plus 2 class and last time we have discussed the topic related with electric field. So now we are moving towards our next article related with electric field, that is electric field intensity due to a point charge. So here we will discuss the three similar articles of electric field in which we will find out the value of electric field due to a point charge, and then in the next article we will find out the value of electric field due to discrete distribution of charges, and the next one we will find out the value of electric field due to the continuous distribution of charges, because we have discussed earlier I think that there are two types of distribution of charges. One is discrete distribution and another is continuous distribution. So we will find out the value of electric field due to different distribution of charges. So in this article there is a single charge. We will take the single point charge due to which we will find out the value of electric field at certain points. Suppose we are taking this diagram in which we are taking the point, suppose P. So we need to find out the value of electric field at point P due to the charge capital Q which is placed at the point O, which is the origin of this axis. So what we will do to find out the value of electric field at point P, we will put a test charge Q naught. We will put a test charge Q naught at point P. Now what we will do, we need to find out the value of electric field at point P or on the test charge Q naught due to this charge capital Q. So you have done the Coulomb's law. When there are two charges separated by certain distance, here the distance is R naught. So what will happen? The charges will exert force on each other. So according to Coulomb's law, the force on this charge Q naught due to this capital charge Q is equals to 1 upon 4 pi epsilon naught capital Q and Q naught, because we have two charges here, capital Q and Q naught. Capital Q is the charge because of which we need to find out the electric field, and Q naught is the test charge at which we have to find out the electric field. So our charges are here Q and Q naught, and the distance between them is R naught square. Because we are talking about vectors, so we will put the unit vector here because we are doing this article in a vector form. So this will be our first equation. And then in this article we need to find out electric field. So according to the definition of electric field intensity at certain point because of certain charge is force per unit charge, force per unit test charge. So here this is a mathematical form of electric field. Now what we will do, we will put the value of F on this in the second equation. So when we put the value of F here, we will get 1 upon 4 pi epsilon naught Q naught R naught square and R naught unit vector, and here there is a Q naught, additional Q naught, so we will put here additional Q naught. What will happen, because Q naught is in numerator also, Q naught is in the denominator also, this will cut down and we will get this equation. So this is a value of electric field at point P due to the charge Q. Now you can put the value of R unit vector. We had discussed earlier that the value of certain unit vector is equals to the vector divided by its magnitude. So when we put the value of R unit vector, so this will be the vector divided by its magnitude. When the magnitude attached here, it will become R naught cube from R naught square. It will convert R naught cube from R naught square when we put the value of R unit vector. So this is the value of electric field due to the charge Q at point P where test charge Q naught is placed. So here we will do now the same thing with another situation when the Q charge is not placed at origin. In this case, the Q charge is placed at origin. Now suppose let our Q charge is placed at certain point A, and the distance of this point A where Q charge, capital Q charge is placed, suppose this distance is R1 vector, and another point is P where we have to find out the value of electric field due to this charge Q. Suppose the distance of this P point is R naught vector. Okay, so now the distance between this q charge and this q naught charge is suppose r10 vector, because we need to find out the distance between two charges to find out the force according to Coulomb's law, and the direction of force will be in this, because we are finding out the force due to this charge on this charge. So the direction will be AP. Okay, so this is the diagram for this similar article. Now we need to find out the value of electric field due to this q charge on this point P. Similarly, we will apply the Coulomb's law, we will get this force. But here, when we write down the value of force, here the distance will be different. The distance will not here, because the distance between two charges is r naught. So we put here the r naught. But here the distance between two charges is r1 naught. So we will put the distance here is r1 naught vector. So it will be q naught divided by r1 naught square r1 naught unit vector. And when we apply the value of unit vector, we will get 1/4 pi epsilon naught q naught r. This will convert into cube from square, and this will convert into vector. So this is the value of force, and when we put this value of force in electric field, we will get 1/4 pi epsilon naught q naught r1 naught cube and r1 naught vector, because electric field is force divided by q. So we have this force and divided by q. When we divide it by q naught, it will cut down, and we will get the value of electric field is 1/4 pi epsilon naught q upon r1 naught cube r1 naught vector. Okay, so next step is we need to find out the value of this vector. What we will do, we will apply the triangular law of vector addition. Okay, so according to triangular law of vector addition, this vector, because these two vectors OA and AP, they are in the same direction. So according to triangular's law, OA vector plus AP vector is equals to the resultant vector in the opposite manner, and we have the vector in the opposite manner is OP. So our resultant vector is OP. So OA is what? R1 vector plus EP is what? R10 vector, and OP is what? R0 vector. So we need to find out the value of this vector. So it will be R1 naught is equals to R naught minus R1 vector. So put this value here. We will get the electric field is E is equals to 1/4 pi epsilon naught capital Q divided by, when we write this in the vector form, we will put the bar, because this is magnitude. So we need magnitude here, and put the value of this R0 vector R1 vector cube, and put the value of this vector. This will be R0 vector minus R1 vector. So this will be the final equation. This is the final equation of electric field at P due to the charge Q, capital Q. So there will be the two cases when the capital Q is placed at origin, and when the capital Q is placed at certain points, for example, say A. So, okay, so this is very simple article. We have just applied here the Coulomb's law. According to Coulomb's law, we will write down the value of force, and after that we will put the value of force in the definition of electric field. We will get the value of electric field. Here we will, in second case, we will also apply the triangular law, because here the distance will be between the two charges will be R1 naught. To find out the value of R1 naught, we need to apply the triangular law of vector addition on the triangle OAP. According to triangular law of vector addition is what? The summation of two vectors taken in the same order will be equal to the vector taken in the opposite order. So that's why we will write out here OA vector and AP vector. The summation of OA vector and AP vector is equals to OP vector, because OP vector is taken in the opposite manner here. So after putting the values, we will get the value of this vector R1 naught, and we will get the result, final result here. So this article is very simple. Take the screenshot of it and enjoy this article. Thank you.